Let's look at a real life example of how we can use real life information, how we can use an equation with real life information to kind of make a prediction or figure something out. If you look at this example, it says all the employees of a garden center are given a 40-cent per hour raise each year. Now then it says you make $7.50 per hour after 3 years as an employee. Now again, to write an equation, we're going to use slope-intercept form, and we need to find two things. We need to find our slope, and we need to find our y-intercept. Now if you think back to before, when we talked about using real-life examples for these things, we always said our slope is our rate of change, how much something is changing as the days go by or hours go by or years, whatever. And then our y-intercept is always our initial value. Well, if you look here, it says they're given a 40-cent per hour raise. That means 40 cent per hour raise each year. Okay, so after year 1, we're getting 40 more cents. After year 2, we're getting another 40 cents, so 80 cents total. After year 3, now we're getting a total raise of $1.20. So this is our slope. It's our rate of change. So we know that our slope is going to be 40 cents. Remember, B stands for our initial value. Don't automatically assume that the $7.50 is our initial value. Initial value would have to be what you make at year 1. This says you make $7.50 per hour after 3 years. So after 3 years, you make $7.15. We can use that idea of setting up an ordered pair, setting up a point. Okay, remember, setting up a relation. Okay, after 3 years, you make $7.15. Keeping in mind that this is our x value, this is our y value. Okay, and again, the reason, guys, I put 3 in for x right here is that when I talked it through up here, I get 40 cents per hour each year. Okay, so we're getting 40 cents each year. I said after 1 year you make 40 cents more, after 2 years you're going to make a total of 80 cents more. So that's our independent variable here, our x. Okay, the number of years is what I'd substitute in for x, and that's why I listed the 3 years as the x value and the $7.50 as our y value. Okay, now using our slope-intercept form, plug in what you know. I know m is going to be 40 cents. I know x is going to be 3. I know that my y is $7.15, and now I can solve for b. 40 cents after 3 years is $1.20. And then we can just subtract that from each side. Oops. Sorry, decimal point goes there. And if you go $7.15 minus $1.20, you get $5.95. That's B. That's your initial value. So the formula, the equation we have, y equals your slope, which is 40 cents, times the number of years you've worked, plus your initial value, your initial wage, $5.95. Now we can use that to figure out what your salary would be after 6 years. In fact, all we have to do is plug in 6 here for x. So our hourly salary is going to be 40 cents times 6 years plus our initial salary, which was $5.95. Typing that into a calculator, you come up with $8.35. So your initial salary when you first started working was $5.95. After 3 years, you were making $7.15. And now after 6 years, you would be making, as long as this stays true, as long as you do keep getting 40 cents an hour raise every year, after 6 years, you're making $8.35. So again, keep in mind with your slope-intercept form, m is still the slope, b is still the initial value, except in these problems you won't be given the initial value. Okay? Create an ordered pair, plug it in, solve for b, and then you are able to write your equation and use it to figure out things like how much money you'll be making after 6 years.